Okay, so here's part two of the screencast that accompanies this PowerPoint on optical atmospheric phenomena. You may have seen this before. This is referred to as a lunar corona. So we have here sunlight that's reflecting off the full moon, and then here in the foreground are some thin clouds. And then if the conditions are just right, the clouds will kind of act a little bit like a prism and then disperse the sunlight. Remember, that's what moonlight is. It's just reflected sunlight. It will then disperse the sunlight into its component colors like so. And you can see that nicely here in this photograph. Okay, this photograph here, here, and here are different photographs of the same thing, which is referred to as a glory. So what you're looking at here is a combination of dispersion. You could see component colors, for example, associated with the sunlight, and diffraction. So in this particular photograph of this kind of glory, which is called the specter of the Brocken, you have here a person, and then behind the person is the sun, and then therefore the shadow of the person is being cast onto mist, which is actually right here just in front of the person in the foreground. And then as the sunlight diffracts around the person, it starts to split up into its component colors, which you can see here, and also a little bit right here as well on the mist that is right in front of the person. Basically, the same thing is happening here with this nice photograph here. You've got this plane here, and then you've got the sunlight itself behind the plane, casting the shadow of the plane in this manner off into the distance, and then you can see a glory here around it like so. The sunlight itself is behind the plane, and then the observer here is sitting at the window, and then photographing the shadow of the plane that is cast into the distance. Okay, this right here is called a Heiligenschein, which is German for a halo of light. It's specifically referring to this white light that you see right here around the silhouette here or the shadow of this person, or the white light here that is cast here like so around this shadow of this balloon. This effect is caused by basically white light from the sun reflecting within individual water droplets when the sun is low to the horizon, like during the early morning hours if it's a nice humid day. Okay, this is called the Twilight wedge. I'm sure you've seen this before. You're only going to see this, for example, right after sunset if you look, say, towards the east, or right before sunrise if you're looking towards the west. So in this particular photograph right here, for example, basically this photograph was taken just after sunset. So the person is facing to the east. And then you can see right here, literally the shadow of the Earth itself being cast onto the atmosphere. Same thing right here in this photograph as well. This is what is called the Twilight wedge. Okay, here's a nice photograph of crepuscular rays. I'm sure you've seen this before from, say, sunlight peeking in between holes in the clouds. When you look at the crepuscular rays, it's very easy to get the idea that all these rays here are at different angles. It's actually not the case. All of the rays are actually parallel to each other, and then you see the rays just receding off into the distance. It's an optical effect that's sometimes referred to as foreshortening. You could see the exact same thing, for example, here in this photograph. If you take a look at the white stripes here associated with this road, it looks like the white stripes are converging to a point here in the distance. That's, of course, not the case. The white stripes here are entirely parallel to each other. Same thing with the crepuscular rays here. Okay, here's a nice picture of what is called an iridescent cloud. Every now and then with really high, thin cirrus clouds, you'll have the dispersion of sunlight into the component colors, resulting then in this phenomenon. Okay, here's a weird mirage. So this is what's referred to as a fata morgana. You could see these here in Southern California on really hot days, particularly the atmosphere is kind of dirty, and you can see it out over the water. What you have here is a nice boundary between cold air immediately above the ocean and warm air above. And then take a look at this right here. What you're actually seeing right here is an image of these objects right here, which are right on the horizon, being reflected off of that boundary between the cold air and the warm air above. If you look carefully at these reflections, however, you'll notice that the reflections are actually upside down of the actual objects themselves. Okay, here's another very startling example of a fata morgana. Take a look at this. So you've got this ship here in the foreground. There's this nice boundary between cold air and warm air like so. Pretty obviously the boundary is right here. And then you can see an image of the ship upside down reflecting off of that boundary. It's actually an example of total internal reflection. Here's another example of this that you probably have seen before. This is called a desert mirage. Take a look carefully at these reflections here and here and here and so on. It's actually reflections, for example, of these rocks actually upside down. This right here is actually an image of the sky upside down. In this particular case, the order of the air is actually reversed from the previous photograph. You have really hot air just above the ground of the desert, and then cold air above. Basically, the boundary between the two is right about here. Okay, lastly, here's a nice sunset mirage, as it's called. You'll see this every now and then with the setting sun, particularly if the atmosphere is kind of dirty. What you're looking at here are just different indices of refraction at different layers of the atmosphere, causing this really distorted image of the sun as it eventually sets. Sometimes the images themselves will be split up in this manner, and it appears to be like multiple images of the sun as it's setting. Sometimes the sun will really appear to linger on the horizon for quite a period of time due to this refractive effect. You can usually see this around here, for example, in the late spring and early summer months. The atmosphere itself has to be pretty dusty, however, in order for this to occur. Okay, that concludes this screencast here on optical atmospheric effects. I've posted for you this PowerPoint in the folder. I also have posted for you a nice link for you to examine where I've gotten a lot of this detail from for this PowerPoint called Hyperphysics. That link is in the folder, as well as that YouTube video that I mentioned earlier about sundogs as seen from a ski resort in Sweden. So I encourage you to take a look at all of that stuff.